So we shall discuss in a first section of biostatistics. As you know, statistics consists of two sections. First section is descriptive statistics, mostly easiest and simplest way, as I think, because it's only discussing how we should summarize and how we should present our data in easy way. So mostly at this section we should discuss how our data could be presented. For first of all, we should start introduction. What is biostatistics? What is statistics as general way? Statistics is a field mostly concerning or about collection, organizing, summarizing, analyzing of data. So mostly discussing issue when we are in statistics is data, how we could manage our data in an understandable way. The second section of why we study in statistics is to draw our decision inferences about our data when only part of data is observed and other parts is also is missing. So we should try to take a decision about what's actually the data is concerning. So statisticians try to interpret and communicate the result with the others in an understandable way, and easily and simply, as visually, as a table, as a graph, and something else. So what is data? Data is a raw material of statistics. Data, first of all, data comes from a number or measurable units we are using to change into understandable and summarizable way. So why we define data as a figure? Figure results from process of counting, comes from counting, from taking measurement. For example, when we are in hospital administrator, we count the number of patients we have visited for our section of hospital. This is called counting. Also, nurses make measurement like weight of patient, like blood pressure of patient. All of we call this into measurement, so that every data comes into two methods, either for count as a number or for measurement as a unit. What's variable? Variable is characteristics that can take different value, either in different person, either in different place, or either in different things, so that we say every data can take different value is a variable. In a variable, we can take example like heart rate, like height of adult males, like weight of school children, age of patients seen in dental clinics. In biostatistics, we could divide it. Biostatistics is application of statistical method and reasoning to biologically medically, and public health. Also, epidemiology and biostatistics, we can call it the tool of public health. If you are an expert in epidemiology, if you are an expert in biostatistics, you have tool, you can work in the field of public health by analyzing data, by interpreting data, by every side of data of medical issues. You can interpret it in an understandable way. So biostatistics we call tools of statistics employed in many fields, not only specific in one section, either in business, in education, in psychology, in agriculture, or economics. When the data analyzed, we derive biological science, medicine. We use inside of biological science, we call biostatistics. Originally, the examples will be the living thing. The examples will be medical issue to discuss particular application of statistical tool and a concept. Okay. Types of variable. Variable could be quantitative or could be qualitative. Quantitative means measurable number, have a number, kind of number. Quantitative variable, it could be measured in a usual sense. For example, height of adult. You should take as example by counting the height of individual adults. You should write numerical way. The weight of preschool children, the age of patients seen in dental clinics, like other side. What is qualitative? Qualitative is kind, indicators. Many characteristics are not capable of being measured. Some of them you can indicate in their shape, you can indicate in their color, you can indicate in their format, you can indicate in their event way. So that we call kindness, not numerically, not number based. For example, classification of people in socioeconomic groups. Or also the higher colors, the color of your hair, the color of hair also should be qualitative method. Types of quantitative method could be discrete numbers or continuous number. Discrete variable or discrete number is the number of whole numbers without decimal point. It's characterized by gap or interruption in values that it can assume as way of whole number. It comes as whole number, like normal numbers values. For example, number of daily admission in general hospital. You must only mention actual number, not use decimal number. The number of decayed or missing or filled teeth by children in elementary school. In continuous variable can assume any value within a specified relevant interval of values assumed by variable. For example, height. Height mostly comes as decimal point. For example, my height is 1.8. At that side, we are not using whole number only. We use continuous number having decimal issues. Like weight, like scale circumstances, no matter how close together to observe height of two people, we can find another person whose height fall somewhere in between. So that continuous variable could be decimal. Types of qualitative variable, also known as scale of measurement. It could be nominal, ordinal, scale, and as I think it was 4. Nominal, ordinal, and scale. So that nominal, mostly quantitative based, having only name origin, no have odd arrangement or no have orders. Like the name of male and female, they are only name. It comes who's first, who's second, no matter, no arrangement it. Sick and well, no arrangement it. Marriage, single, so something like that. Ordinal numbers, whenever qualitative observation can be ranked into orderly according to their criteria, like blood pressure could be high, could be low, could be medium. Grade of exam, excellence, very good, good, very, something like that. Also, when we are counting data, mostly we are facing how in which way we can collect the data, either in population side or either in sample. Population is the largest collection value of random variables, of which we have interest in particular time. So that population, it comes in different way. So it takes large numbers to count at simple way. Weight of all children enrolled in certain elementary school. If you are individual, you cannot count all of all. So that population could be finite number or fixed number or infinite number or unfixed number. You can split. Finite means limit number or fixed number, countable, while infinite means immeasurable, countless. Sample is subset of population. You can take sample from whole population. You cannot count whole population at once. For example, if I am studying in weight of children enrolled in all elementary schools in Mogadishu, it's difficult for me. But if I make specified for a specific place, a specific school, a specific class, that is called sampling. is a part of population. Also is a subset of population. For example, the weight of only fractions of this children in a specific place, in a specific school, something like that. Also, we need to understand difference between statistics and parameters. Statistics also same as sample. Descriptive statistics mostly measures computes the data as a sample, not data as a population. It's difficult to calculate or to measure in mathematical way for whole population data. So when we use the word statistics, we are going to understand the data is a sample basic, not data as whole population. The parameter is a descriptive measure computed from the data of population. Since it's difficult to measure parameter from population, sample is drawing of size of any numbers from the data. So we are measuring statistics as we are using sample. In section number 2, we are going to understand descriptive statistics, mostly data presentation issue like frequency distribution and this for discrete random numbers, for whole random numbers. So as we know, frequency distribution is a tool of statistics, mostly used to present data in a simplification form. If data is raw data, you can make simplification raw as simply understandable as table format. So that table we can call it frequency table, also frequency distribution. Suppose this example. Suppose that we are taking sample size of 16 from children in primary school and get the following data about their number of their decade, about the number of their decade it is. So that we have total 16 numbers of teeth decay. First individual have 3 teeth decay. Second individual has 5 teeth decay. Up to 16 numbers. So that we take that number into frequency table by using variable name, by using frequency number, by using relative frequency. So we must understand what is number or what is a variable name. The variable name is the name of numbers of decayed teeth. Numbers of decayed teeth. Numbers that children have decaying teeth. So that we enter in this table, we use this table. This is a variable name. We can call in another way in class interval. We should make that number. So frequency number, that means how many individuals have zero. That means have no teeth decaying. The only one number is no teeth decaying. While one teeth decaying individuals are two children. 2 teeth decaying are 4 children. 3 teeth decaying are 5 children. 4 teeth decaying are 2 children. These are the frequency numbers of individuals. These are the teeth numbers of decay. So that we have sample of 16. Relative frequency means we calculate percentage of each frequency number. For example, we divide 1 to 16. We get this number. This is the percentage of that number to whole numbers. Also we call it relative frequency. Also in percentage symbol frequency table we use chart, bar chart, like this one. We can present the above symbol frequency table. We use using bar chart. We can get like this one. As you see, number of teeth decaying is in vertical, in a horizontal way, and the vertical way is number of individuals. So as simple as the table, you can understand what is meaning. Go to back. What is frequency? What is frequency in continuous random numbers? Like class interval, like group, we can call it group frequency. Group interval or class interval numbers of frequency distribution. So that for large sample we can't use symbol frequency table like above. So we need to divide data into groups or intervals. So we need to understand each symbol way to summarize our data in a simplest method. So we can use range, which means the difference between the largest and smallest observation of data, like R is equal maximum minus maximum number minus minimum number. So what is class interval? Class interval is predefined a range or groups used to organize large or continuous data set into manageable category of analyzing. They form backbone of group frequency distribution and histograms. Look at this. Now we have more numbers. We make class interval and we make frequency. For example, we say the age number. If the age between 30 to 39, we have 11 individuals of that age. If we have age 40 to 49, we have 46 numbers, 46 individuals between that age. If we have 50 to 59, we have 70 individuals in that age. Like that, all above. Up to total numbers of frequency. So that this is the symbol or the total number, and this is the age interval. The age interval. This is an example. So to understand simply, we use another two columns. We can call it cumulative frequency and cumulative relative frequency. Cumulative frequency means running totally or adding up as you are going along of frequency in data set. So you can compute adding successively frequency up to the end. Like this way. Cumulative relative is adding up as you go along using relative frequency in the data set. It can be computed by adding successive relative frequency. So we must understand. In glass interval and frequency and distribution of frequency number, we have cumulative frequency. Cumulative frequency means we can add this number to this first number. We can write as same as the first one, but in second number we add this. We have this. That means 46 plus 11, we have 57. Also in this we have 127. 127, we should make subtraction to get real number. To get real number of that. For example, if we have 127, we should make minus 57. We get actual number of this column. So the actual number of this column is 70. Also, this is the missing one. Cumulative frequency also this is missing one. We should add this to this so that 127 plus 45. 127 plus 45. We have 172. 172. And like the way 172 plus 16, we have 188. 188 plus 1, we have 189. Up to that. So we can call it adding up to as long as you are going to the frequency down level. So that in this way, this is a relative frequency, but this is same number to this relative frequency. What this was by making proportion percentage, like percentage or like the formula of proportions, by dividing the this number by each individual numbers, by dividing each individual numbers to the total number. For example, 11 divided by 189, we should get this number. 46 divided by 189, we should get this number. 70 divided by, this is missing as you see, 70 divided by 189, it should be 0.37. 0.3703, like all the way. While 45, we should divide 45 divided by 189. So we should get this number like this way. 16 divided by 169. We should get this number. 1 divided by 89. We should get this number. And combination will be 1. You can calculate it. In cumulative frequency, like the cumulative relative frequency, we should add in relative frequency. For example, we have in first row, we should write same as the first row of relative frequency, but in second row we should add this one. So that I should add like 0.0582 plus 0.2434. So it should be 0.3. It should be 0.3, 0.16. In like way, you should add this number to this number. 0.3703. We should get this number. We should get this number. We add this number to this number. We should get this number. Combination like above. In cumulative relative frequency, we should add in up as long as we are going down comparing to the relative frequency, so that up to getting up to the end. As I think you should understand it. Also, displaying group frequency distribution, we should use group frequency distribution. We should use graphically, like histogram, polygon, and curve, as you see in this table. This table is a histogram. This table is polygon, and there is missing table of line, curve line, or curve table, something like that. In section 3, we should enter measures of central tendency. The measure of central tendency is measuring which indicates where the middle of that data. We are going to understand how our data has center size, to understand how the data is distributed. The three most common used measures for measuring central tendency, we should use mean, median, and mode. Mean is the average of data. Population mean, we should say usually unknown, but have not sampling, but have mu summation of sample divided by n. In sample mean, to estimate or approximate our population mean, we should use sample mean, which is summation of x divided by n. This formula is ungrouped data. Calculation of mean for ungrouped data is here. Data, we have sample size of 10 individual age. 10 individual age. Individual 1, age 46. Individual 2, age 28. 28, individual 3. 24, 61, individual 4. Individual 5, 31 age. Like that. So 10 individuals and their age. How we should make? In summation of x, we should add up the total numbers of all ages divided by their original total number. The original sample number is 10. The whole number we should make adding up to, so that we get sample mean. So it's simple. You can make symbol in calculation using my calculator. What is the probability of mean? The probability of mean is uniqueness. That means the given set of data, there is no one or only one mean, no other issue. Symbolicity, it's easy to understand and easy to compute, easy to calculate. Affected by extreme value, sometimes it can affect by extreme value. You should get two different data with same mean, since all value into computation. For example, assume that this number, this is a value number. If you have 115, 110, 119, 117, 121, 126, we have 6 numbers. Combination of all will be different. By divided by 6, you should get 118 as mean. While in this data 75, 75, 80, 80, 100 8, you should get same mean, but the data number is different. But the mean of the data is same. The value of this is not representing set of data as whole. Medium, we can call it ordering data to calculate the middle one, or to calculate which observation we get into that, so that when ordering the data, it's observation that divide the set of observation into 2 equal parts, such half of data are before it and other data after it. So if n is odd, for example, if our total number is odd numbers, the medium will be the middle of the observation. For example, it will be n plus 1 divided by 2, the ordinary observation. If, for example, we have 11, then the medium will be 8th observation by adding one extra, so that it's not even. It's not even, it's odd number. If the number is even, there are 2 middle observation. The median will be the mean of these 2 middle observation. It will be mean of n divided by 2. That's the calculation symbol. Now I need to add plus 1. Or we can make another method, n divided by 2 plus 1. For example, if you have total number of 12, then the median is 6.5 observation, which observation halfway between 6th or 7th divisions. Example, for the same random sample, the order observation will be 23, 28, 28, 31, 32, 34, 38, 37, 46, 50, 61. This is a sample, and this sample is same with sample of 10 individuals of their age in last example. Since total number is 10, then the median will be 5.5 observation, which is the middle numbers 32, 34 divided by combination divided by 2. Probability of mean is same with the probability of median. Probability of median is same with probability of mean. Uniqueness, which data is only one or only one medium. Simplicity, data is simply and easily to calculate, but it's not affected by extreme values. It cannot affect by extreme values. Every data has unique medium. Mode is the value which occurs most frequent, which means having highest number or having doubling number. If all values of different is no mode, sometimes there is more than one mode. For example, some random sample size, the value is 28, repeated 2 times. Go back to this, which is we have 28. So this number is repeated in 2 times, which means this is the mode number. Probability of mean, probability of mode, sometimes it's not unique. It could be different. It may be used by describing qualitative data. It's not affected by extreme value like median. Example, find the mean and mode of the following relative frequency in as a group data. As you see, we first calculating the mean, and second we are going to understand the mode. So by making calculation of mean as this formula, we are combining the total numbers of sample frequency. For example, if we have relative frequency 10, 18, 28 up to 10, we have 66 summation of fx divided by the total number, which is 10. So we have 6.6 mean. In mode, directly we are seeing that the frequency, the highest number in the data is 28. As you see, it's not 10, it's not 18, it's not 10. The highest number in the data is 18. So that 28 is the highest number, and the age number is 7. So the mode would be 7. Also find like this way in a combination of two numbers. For example, this is a glass interval age. The highest mode number is 32. So 32 we should say is the highest number in accounting for 4 individuals greater than for all over. So we say 7 up to 9 is mode interval, and can't be exact number on the interval with highest frequency. Like this way, as graph, we also indicate mode that has highest frequency. The mode that has highest frequency. As you see, the mode, this is a 3. 3 the highest frequency. We have 5. So 3 is the mode number. Also formula. In descriptive statistics also we should use by measuring dispersions, how our data is spread into the normal distribution. The measure of dispersion conveys information regarding the amount of variability present in the set of data. So we have formula to understand how we should use our measuring dispersion of our data, measuring the spread of our data in normal distribution. If all values are the same, that means there is no dispersion. If all values are different, that means there is a dispersion. The dispersion means the spread. There is a difference of spread. If the number is same, that there is no spread. No, there is no distribution. There is no dispersion. If the values close to each other, that means the amount of dispersion is small. If the values are widely scattered, that means dispersion is greater. So measure of dispersion mostly in a 4 section. First section is range. Section number 2 is variance. Section number 3 is standard deviation. Section number 4 should be coefficient variance. So what's range? Range is calculation of the largest number in your frequency or in your glass interval minus the smallest number in your glass. So XL minus XS. L stands for largest value, S stands for smallest value. As you see, note range concerns only on 2 values. We have ungrouped data of age of different individuals, like above. So that we are making simplification to understand how range is. First data is unarranged data. 43, 63, 61, 64, 65, 38, 59, 57, 57. So that we should first step we should make rearrangement. Starting the smallest number up to the highest number. The smallest number clearly is 38, 43. Up to the highest number is 66. So we extract that small and largest number. So we can find it by abstracting largest number to the smallest number. 66 minus 38. We receive 28. Invariance is measures dispersion relatively to the scatter of value about their mean. If we are going to determine variance, we must have mean. If we have mean and data, and easily we should calculate by our variance. For example, calculation of variance, step 1 is to get mean. This example gives you mean age of 56. Find sample variance of age mean 56. So step 1, finding mean, we have mean. Step number 2, abstract the mean from each data. Go to the age data, the underwood data. We should use this data. We choose this data. So in our number of 56, we should abstract to all of this. Look at this. We make the age number minus our mean. After that, we should make square up to the all divided by the total number of 10. By simplification, the step number 1, abstracting mean. Step number 2, squaring each result. Step number 3, summation of square values. After that, step number 1, abstracting. Step number 2, squaring. And step number 3 is adding of square values, so that we receive 810 divided by 9. Where is 9 come from? Because total number minus 1. If we have 10, we should make 10 minus 1. So we receive 9. So 810 divided by 9, we should get 90. 90 is our variance. If we have variance, it's symbol for calculation of standard deviations and coefficient. In population mean, we should use mu square, while standard deviation, we should use a square root of variance. If you have variance, we should make a square root like above. So we have 90 in variance, we make a square root of 90 to get standard deviation. Symbol of standard deviation will be standard deviation square. Population standard deviation will be square root of population mean. So standard deviation is a statistical metric that measures average amount by which individual data points in data of as you see, data set is differ and deviated from the mean, understandably and easily way you can see. The coefficient of variations. We should make calculation of two different samples to know how their comparison of their dispersion or their spread of data. So coefficient of variation, CV, is measures used to compare dispersion in two set samples of data which seems to be independent of unit of measurement, so that we have sample divided by mean. So S stands for sample standard deviation and X bar stands for sample mean. We should use this example. Suppose we have two samples of human male yield the following data: age 25, sample 1, 25-year-old, and mean weight is 145 pound. Standard deviation is 10 pound. Like sample 2, we have 11-year-old, 80 pound weight mean, and standard deviation of 10. As you see, sample 1 is a greater number than sample 2. But when we are going to calculate, we are using the coefficient variation formula. So we must calculate sample 1 differently to sample 2 differently, so that we take population, we take standard deviation, and we take mean weight of individuals. In sample 1, standard deviation is 10, mean weight of individual is 145 times 100, which is 6.9. In sample 2, we have 10 pound standard deviation divided by mean weight of 80 times 100, we have 12.5. So the sample size, sample 2 have greater variation to sample 1. The age of 11-year-old in sample 2 is more variation than the age of 25-year-old of sample 1. Okay, now we should enter probability. As you know, probability is getting equal chance of calculation of equal chance formula. Concept of probability frequently encountered in everyday communication. For example, physicians may say that patient has 50-50 chance of surviving certain operations. Another physician may say that she is 95% certain that patient has particular disease. Most people express probability in terms of percentage, but probability mostly based in numbers, less than number. For example, probability is between 1 up to 0. If we say 50%, we cannot write 50. We use 0.5. If we say 20%, we use 0.20. So that in formula, it's more convenient, but it's more convenient to express probability as fraction, as point. Thus, we measure probability of occurrence of some event by number between 0 to 1. The more likely the event, the closer the number to 1. For example, if we say this is a 95%, we should not write that. We should not write 95. We should write 0.95. An event can occur has a probability of 0. Sorry. Definition. What is probability? In biostatistics, probability is quantifies uncertainty of health outcome, uncertainty of any case. It measures the chance of event happening within a period of group by expressing a number of between 0 to 1. 0 we should say impossible. 1 we should say certain. So certain means sure to get that number. What is measures? Mostly in biostatistics we should measure disease occurrence, we should measure treatment efficacy, we should make diagnostic accuracy and risk factors. How many candidates it comes? Kind and types of probability should be classical probability based on equal chance. For example, if we say we have chance of newborn being boy or girl, that means every variable has 0.5. Or we should say we have chance of corn to be a head or tail. Or empirical probability or relative probability. Calculate from observed data or historical clinical data. For example, tracking thousand individuals to see how many of them develop side effects by using a specific drug. Also, conditional probability, likelihood of event occurring given that another event has already occurred. As we also explained in go to epidemiology section 2 in last video, we explained probability of testing positive patient of actually has disease. Classical probability we use when all outcome of sample is equally chance, equal likely of occurrence. For example, rolling fire, die, or flipping coin. Formula: probability A is equal probability NA divided by NS. Probability A stands for probability of event A. NA stands number of favorable outcome we are likely to occur. Must be small number. And NS, the total number of possible outcome in the sample. For example, if we throw dice has 6 sides. We are interested in number 4, so that we are interested in only one section, so that we say 1 divided by 6. Dice has 6 sides. We are interested in 4 in one side. So in one side. So the formula will be probability will equal 1 over 6, like that. For example, for classical probability, calculate the probability that child inherits recessive gene disorders when both parents are carriers, not affected the genetic disorders, have only carriers, having a chromosome A and A small. Determine sample space by using Banach square, showing how 4 possible genetic combination can occur. For example, A capital, A capital, A capital, A small, A small, A capital, A small, A small. That means we are drawing how possible should occur the genetic value of mother and father before childbirth. So that we have, therefore we have S4. We have totally occurrence of data should be 4 phase. A capital, A capital, A capital, A small, A small, A capital, A small, A small. The occurrence is 4 phase. No other phase we have. After that, now we count variability of outcome. Only one combination can have negative effect of occurrence of genetic inheritance. For example, A small, if the newborn baby should have A small, that means the baby should have genetic disorders of coming from his father and mother, having disorder, so that in the case occurrence will be 1. The applied formula by probability disorder is equal NA divided by NS, which means 1 divided by 4. After calculating, we have 0.25. So we can say the newborn baby probability of getting inherited recessive gene disorder should be 0.25%. Conditional probability also measures likelihood of event occurring given that another event should occur. So that we have been using by calculating epidemiology in specificity test, by sensitivity test, by using that formulas. So that the formula is B probability should be probability of A and B, and probability A summation with B divided by probability of B. So that probability of A divided by B, that means probability of event A given event B. Probability of event A given to me probability of event B. In probability A summation B means probability that both event and B are jointly can occur at the same time. Both A and B can occur together. Jointly probability, we can call it jointly probability. In probability B, probability of event B can occur. Let us take example. In a clinic, find 8% of population test positive for virus. So that we have 8% of all patients coming in our hospital have positive virus. We have probability of 0.08. Only 3 of them of population have both test positive and actual has the virus. So we are now realizing that there is some hierarchical testing issue, because 8 was total positive, but 3 was actual positive. So there is missing point in there. So what we are going is, if the patient test comes back positive, what is the probability that actually have the disease? What is the actually the patient after coming back as positive, what is actually have the disease? First, we must identify known value. We have 2 values, BT, which is 0.08, and BDT, which is 0.03, because positive test D and actual disease is T. While in before we have only 8 test positive by BT. Apply the formula. The formula was dt, probability of dt is equal probability of d and t combination jointly divided by probability of t, so that probability of dt is 0.03 divided by probability of t is 0.08, which is 0.375. That means 37.5% should be actually have the disease. In relative probability, we use when probability cannot be reduced theoretically, cannot be extracted theoretically. Instead of probability estimation basis, not have actual number or empirical observations or historical data. For estimation in historical data or repeating in experimental over a large number of traits. For example, if we have BA is equal F divided by N. Probability of event A stands for BA. F stands for number of times event A occurs in experiment or observation. N means total number of traits we have tried multiple times, or number of observations we have made last sessions, so that the total number of observations we made is the N number. Let us take example. So that mostly based on epidemiology. Hospital tracks by visiting patient, 1,000 cardiac patients. After the start, there were cardiac disease patients, but now leaving the hospital. We must track them to determine which one come back readmitted in our hospital. Within 30 days, 50 of those of 1,000 cardiac patients are admitted. That means coming back to hospital. Estimating the probability that new cardiac patient will be readmitted. So we are going to estimate probability that new cardiac output will be readmitted by using this formula. First step is to identify observed frequency. That now the number of readmitted patients is F is equal 50. Identify total trait. Total sample size was 1,000. Apply the formula. Probability of readmission is equal F divided by N. Probability of readmission is equal 50 divided by 1,000, which means 0.05. 0.05, which means probability of cardiac patients to come back to hospital for another time is 5% or 0.05 in probability. There is also formula. We described it in last session in epidemiology, made by Biostatistics. Biostatistics is extension of conditional probability that calculating probability of event based on periodic knowledge of condition related to the event, and he made a table known as 2 by 2 table. If in this case, if the patient has to do blood test in the laboratory, sometimes result could be positive, has a disease. If the result is negative, he doesn't has the disease. Sometimes there is another options we have: false positive, false negative. Look at this table. In following case, the patient has the disease, which means positive case. The patient doesn't have the disease, which means not have the disease. So he called patients with positive test and having disease, positive test and having the disease patients, he called sensitivity. We explained in last session. Also, patients with a negative test and without disease, he called specificity. While the two sections he called wrong test. at that time epidemiologists use this table, 2 by 2 table, and turn in this the wrong side into false negative, false negative through positive, so that as you know in the formula we have explained. Thank you very much. We are finalizing in the section 1 of biostatistics. If you have more information, or if you have